Do you want to get started?
Should we give it one more minute, see if someone else is going to join?
Okay.
Do we have a scribe?
Stefan, this is Dan. I had volunteered to scribe for the first 30 minutes.
Okay. I think perhaps I can take over after you then. That's great.
Okay.
Dan.
Harold is here.
Hi, Harold.
Yeah, perhaps we should get started then.
Okay, excellent. All right.
So I can talk for the first couple of slides. So this is the usual stuff. Let's move on. Yeah, as usual, we hope to be able to resolve some issues and perhaps make a new editor's draft available after the meeting. And we will, of course, as usual, also send out the decisions made so everyone not on this call can look at them and react or have comments. And then I want to tell you all that we have limited editor resources for a couple of reasons during November, December, and January. So we ask everyone who wants changes or raise issues to the spec to, if possible, also submit a pull request to make the life easier for the limited resources we have for editing. We have considered adding editor resources, but after some discussions and contemplating, we have decided that for this short period it would not make things much more efficient. Okay, now we're moving into this meeting, and I guess you take it from here, Bernard.
Okay. So the meeting is being recorded, right? I think.
Tom?
There's the IRC channel, so people should get in there. And if you're on here, you probably know the WebEx info.
It is correct that the meeting is being recorded.
Okay. Okay, for discussion today, we actually have quite a bit on the agenda. Hopefully we can get through all of it. We have a section on pull requests and then just issues which don't have associated PRs. Just looking at the issues, we have a bunch of issues relating to ICE. We have a bunch of issues relating to the transceiver functionality, methods like direction and stop, what exactly they do. We have some material on error handling and stun OAuth, which are from the previous meeting. So we're hoping to make progress on a bunch of these things and make sure we know what the next steps are. All right, so pull requests. The first one is what happens when transceiver.stop is called. But first I want to take a little digression to talk about some of the functionality we already have and just make sure everybody is on board with what's already there. So transceiver.stop.
And just it turned out to be a rather long list of things we have, and we're going to spend the time until the end of the meeting, and then we'll stop. But I just encourage you to, if we detect that we're not getting anywhere, let's just table the issue and turn to the next issue.
Excellent, Harold. So
we want stop discussion if there's progress, but we don't want to spend your time badly. Okay, go on.
So just a reminder, transceiver.stop is irreversible, so it's not something you can reset transceiver.stop to false. And it's the sender will no longer send, receiver will no longer receive, and negotiation needed flag is set. Transceiver.setDirection sets the direction but does not take effect immediately. Instead, the future calls mark the media description as described in Jessup. and the negotiation needed flag set. So we're going to get into both of these in a few minutes, but just to remind people where we are. Also, we have set parameters, and we have encodings.active. Set parameters, again, the text says, doesn't cause renegotiation, can only be used to change what the media stack is sending and receiving within the envelope. Just to remind people, there is only set parameters for the sender, not the receiver. You can get parameters of both, but only set on the sender. We also have encodings.active, and that means for a sender, the encoding is being sent. Setting it to false means it's no longer sent. For an RTP receiver, there's some interesting text there. It indicates the assist encoding is being decoded. There's additionally some statements about setting it to false or setting it to true. Since there's no receiver.setParameters method, that's really not possible. So there's a PR 926 that cleans that up a bit, just to say that it reflects whether the encoding is being decoded or not. All right. So issue 871 is what happens when transceiver.stop is called. So we had a question about whether when you call transceiver.stop, you have an unended event for transceiver.receiver.track. And then Adam pointed out we didn't really have enough detailed steps to know exactly what happened, so we followed this one instead. So here is what the proposed text is to be added to the transceiver.stop description. So we say that stopping a transceiver is irreversible. It doesn't say that explicitly, although I think most people seem to understand that's what it does. And the rest of it is straight from JESIP, will cause future calls to generate a zero port. As defined in JESIP, when the method is invoked, the user agent must run the following steps. At first, if it's already stopped, you abort those steps because you don't need to stop it again. Then if the connection is closed, you throw an invalid state error exception because no point in calling stop on a closed connection. You stop sending media with a sender, stop receiving it on the receiver. You set the ready state of receiver.track to ended, set.stop to true, and then mark the connection as needing negotiation. Does this kind of jibe with what people think transceiver.stop does? Or is there anything else that it ought to do? You'll notice there's no toggling of the active flag or anything of that nature here. Because it's permanent, it didn't seem to make sense to do that. Let me put it this way. Are there any objections to this that people see or problems? Okay, I guess just note that, Stefan, and we'll move on.
Yeah.
Okay, so next issue is 908, and it's got to do with the use of the term stopped in the specification. So, and there's a whole bunch of examples of where the term stopped is used. And a question that Taylor brought up is what exactly that means, because as I mentioned previously, we have transceiver.stop, we have set directions, so we can set things to receive only or send only, and then we also have this inactive, and it wasn't exactly clear what of all of these things we mean when we say stopped. So some examples, in closed method, we say senders and receivers are now considered stopped. Remove track, we say if a sender is stopped, abort these steps, and then we say stop sender. In 5.2, we say a sender can be stopped, which indicates it will no longer send. We have replace track. If a sender is stopped, return a promise with invalid state error. Some more examples, 5.4, and this relates to the transceiver.stopped attribute. We say it's true if either stopped has been called or we've caused the receiver to be stopped. This is a little bit puzzling. And then we have insert DTMF where we say if sender's been stopped, throw an exception, or if sender's been stopped, abort these steps. So we're trying to figure out what exactly these things correspond to in terms of these methods and attributes that we have. And it is a wee bit tricky, but PRs 916 and 918 describe the following guesses or the following text substitutions. So instead of saying the senders and receivers are now considered stopped, we say set transceiver.stopped to true. Because this is closed, we're closing the peer connection. it seemed to be something that's permanent, so that's why we use transceiver.stopped there. In 5.1, we have remove track, and I think Dan may have some questions about it, and we think there that this could be referring to, we say if sender is stopped, then abort these steps. And we say instead if transceiver.direction is receive only or inactive, then abort these steps. And if transceiver.direction, and then set transceiver.direction to receive only. There is an issue with that because, as Taylor will describe, just because direction is receive only or inactive doesn't mean the sender is actually not sending. Because it takes effect, it doesn't take effect immediately. So this isn't actually quite right, and we will get into maybe how to fix that in a little bit. But the idea here is just to understand in remove track were we actually talking about, we think this is only about the sender, so we wouldn't want to, set transceiver.stop to true, or test. Maybe the first one is whether transceiver.stopped is true. But so a little bit of uncertainty there about what exactly that we were trying to do there in remove track.
So the operation should be that when you remove the track, you don't send the data from that track anymore. That's the most important thing about the remove.
Is it reversible, Harold?
You can do. I think you can do add track on the RTP sender where you have done remove track, but the data.
So then it's definitely not transceiver.stop.
No, I don't think it is.
Okay.
But the direction could end up in inactive if it was send only.
Yeah. So I guess the question is, Harold, whether these actions are awaiting negotiation or whether they were supposed to refer to the immediate state. If they're willing to wait for negotiation, then I think they're correct as is. But if sender is stopped, abort these steps, right? If we're looking to know whether the sender can send or not, you can't get that from transceiver.direction, and Taylor will talk more about it.
Yep.
But anyway, if you could note those issues, Harold, that would be great. So I'll just leave that where it is because I don't really have an answer right now. Okay. So some more examples. If 5.2, a sender can be stopped, which indicates it will no longer send media. The proposal is just to delete this because we're just not sure whether it's referring to direction or transceiver.stopped or what, and it doesn't seem to be particularly important. We also had a question about replace track. There we say if it's stopped, return a promise. And there we think, but maybe not exactly, that this is equivalent to transceiver.stopped being true because they're rejecting the promise. And if the sender was just, if it was just receive only or inactive, you shouldn't reject with an invalid state error. Does that make sense to you, Harold?
Yeah.
This one's referring to transceiver.stop, okay. And then the last one is actually the definition of stopped itself. And Taylor pointed out that this looks like a typo. It should have said has caused the transceiver to be stopped rather than the receiver, because I don't know what the receiver would have to do with it. So it kind of makes sense. The text does make sense if you substitute transceiver for receiver. So that's what our proposal is there.
It's Colin here. Yeah, I think that's a clear typo.
Okay, good. Okay. And then yet more examples. In insert DTMF, we have, again, if sender's been stopped, throw invalid state, and we think that translates to transceiver.stopped as true. And then if sender's stopped, abort these steps. That one is a little tricky. We think that's transceiver.stopped as true as well. But then the problem comes up, what if the sender can't send? Right, if the actual negotiated direction is receive only or inactive, do we want to throw an invalid state error or abort these steps? And possibly, but the problem is we can't use transceiver.direction for that. because it doesn't take effect immediately. And then, so this one has some of the same issues that we described earlier, and Taylor will get into this in more depth. And there's a question about whether the actual, the active attribute is relevant here or not. Do people have any thoughts about whether an exception, insert DTMF should throw an exception if the negotiated direction were inactive or receive only? Does that make sense to people or not?
Colin here. I mean, I think we definitely need, I won't say exception or whatever, but you've got to be able to find out it didn't work. And I think it's totally right that whether it's going to work or not has nothing to do with, it has to do with the current state of the media flow, not something to do with signaling flow, right? So,
right.
So I think we need to know if it didn't work. Yes.
Right. So yeah, if insert, you don't want to have insert DTMF look successful, but nothing gets sent because the sender can't send.
Exactly.
Okay. So sentiment is that yes, we should take into account whether the sender can actually send, but we don't know how to do that. And maybe Taylor will enlighten us in a little bit. Okay. All right. So that's it for these. I'm going to turn it over to Missy.
Bernard, Bernard, can I put the question?
Yeah.
I mean, the way to stop a sender and receiver now, is that to call transceiver.stop or peer connection close?
Well, so as I mentioned, there are a couple of ways to stop a sender from sending or a receiver from receiving. Transceiver.stop, that's a permanent way.
Yeah.
If it's not going to be permanent, you could call set direction, but it doesn't take effect immediately, and so that's the issue we've been talking about. Yet another way would be for a sender is to do set parameters and use the active attribute to set that to false.
But then it would stop sending, but it wouldn't be stopped as such.
Well, it wouldn't be permanently stopped, so you could reset that active to true.
Yeah, exactly.
Right, but when you use the term stopped, we're trying to figure out what specifically it means in each instance.
Yeah, that's the reason for my question. I think we should move on and clarify that.
Yeah, I mean, I think we've gotten as much as we will. Taylor has a whole bunch of more slides on it, so I think we leave that portion to him for this particular confusion. Okay. So I'd like to turn it over to Missy to talk about the OS token parameter.
Okay. I feel this issue because I detected that it is not handled correctly, and the original text is here. So the credential. In the credential, the original text say that we should pass the access token, and this is not enough to authenticate using the OAuth. And my proposal is to reuse reuse the username and use it as the key ID of the access token, and
which slide do you want me to show?
The previous one.
Okay.
This one.
There are slide numbers. Please use them. 17.
So this is the access token. This is the OAuth client received these OAuth parameters from the authentication servers, and these are the information that the application receives from the authentication server, and from this information, not all information is used during the STAN client authentication. Only the access token, the key ID, the KID, and the key. This is the MAC key. This is what is used as the password. So it is used in the message integrity calculation. And only this information needs to pass down to the ICE agent, in my view. And all the other informations need to be handled by the application, by the OAuth client part of the application. So on the next slide, I created a figure about this. So the OAuth client module duty is to renew and renew the access token. And the stun turn, the ICE agent only getting the information, this tree information. And this tree information, if we reuse the username as the key, and the MAC key as the credential, and creating a new access token in the interface, a new attribute, then we can pass down to the ICE agent this information. I feel a gap between the actual RFC and the WebRTC API. So the RFC is only defining the external observable behaviors and not defining the behavior and the interaction between the stun turn, the ICE agent, and the old client part. So not defining this. The old client is needing some information from the stun turn client. It needs the supported message integrity algorithms, so the HMAC algorithms that the stun turn client supports, because it is needed to determine the key length. What is the MAC key length that the authorization server will create. The session key, I mean, and this way, I think maybe it is worth to write something about this. I don't know your opinion to write and clarify more these things, because it is not easy to understand. I think the actual RFC. So give more examples and speaking more about in browser context, how the old client and the stun client interacts with each other. On the next slide, I explained somehow these functionalities. So the old client part is to store the old related parameters and renew the access token, and the ICE agent need to pass up during the peer connection creation the supported stun turn, the HMAC algorithms, and need to get the key, the MAC key, and the access token parameters. And when the old client renewing this information, then through the WebRTC configuration interface, it should be passed down to the new credentials, the new access token to the stun turn client.
Can you explain a bit more why it's important for the HMAC algorithms to be known during the actual OAuth phase?
The actual RFC is saying that in the example part there is a few lines about the client HMAC args need to determine the HMAC key length. And because the stun, this has some hash agility and accomplish this agility computing message integrity using both HMAC, SH1, and the new SH256 algorithm. So somehow it could set the key length that it is creating. This is the only thing why it is matters, this thing.
But look, I think more clarity is needed here for sure. Not arguing against any of that. We need to write some of this down, and then it'll be easier to send. But I wonder if the OAuth server should be getting that information about which supported algorithms are used based on its relationship with the turn server versus the other way around. Like, I'm just wondering which way. Like, look, we got to use something that's supported by both the server and the client, and they will negotiate later on. But I wonder whether that key length information should match what the turn server does, not what the client does at this point.
It needs to get the information what is the longest key length so what is the strongest algorithm that it is supporting, and what is the longest key length, I think. So if it is supporting HMAC SH256, then it is giving that key, and if it is needed, then it could create a shorter key from that.
Well, let's say the turn server supports new SHA-10,000, okay, in the future.
Okay.
If it holds the authorization server in its relationship with them, hey, I support SHA-10,000, then the authorization server could generate tokens that had long enough keying material to be usable in everything it supports, including SHA-10,000. I mean, I think I think that's how we thought this was going to work long ago. I'm not saying that's how it should work. I'm just sort of I don't understand this well enough, but that's.
So it's important what the client is supporting. So what the client.
It doesn't matter what the client supports, right? Because if the client supports SHA-10 million, it's not going to be negotiated anyway because the turn server only supports SHA-10,000.
Yes, but I think in the actual StanBIS RFC or draft, there is only two arguments there, the SH1 and the SH256. And I think there is a few lines about that maybe later will be updated with new SH1000 or whatever. But there is only two arguments in.
Yeah, I mean, sure. Today you could, but I mean, all of this stuff is about crypto agility for the future, right? I mean, if you just used whatever the minimum life was for SHA-256 today for everything, you'd be good to go and you could ignore all of this, and that's what several implementations do. So, but the question is how do we design this such that we can add a new hash algorithm later? I think that should be our test of whether we got the standard right. Hey, can we add new crypto later without breaking everything?
But when the client will support this, then the authorization server, it will signal through the out client to the authorization server that, hey, I need the SH1 algorithm, and I supporting this, and the authorization server will know maybe that okay, that it needs I don't know 1,000 characters length key. And this way, it will give back this kind of key to the Stanton client through the client.
I guess what I'm trying to say is the browser and the turn server are going to negotiate something they both support when they actually do this.
Yes.
And so all we have to make sure is that one of those two people communicated to the authorization server the maximum, how big, what the minimum size of the key needed to be, right? But we don't need them both to communicate it, and it could be, it seems to me that it could be either one of them could tell the authorization server, make sure the key is at least this big. So I think we have a question of which one of them should tell them that. Should the turn server tell the authorization server how big the key needs to be, or should the web browser via the web application tell it the way you have it drawn in this architecture? And I can see both working. I mean, I'm not like what you're proposing here. Like I can see how it would work. I just suspect that when we wrote some of this stuff, we were thinking about it being the other way, where the authorization server is tightly bound to the turn server in many ways, and that those two would be coordinated to know the information they needed to know about each other to do the right thing on things like this.
Okay, but the authorization server, I think the key is not connected with the turn server directly, because the authorization server creates the session key. This is a temporary thing, so it is not the shared key between the turn server and the authorization server. So if the Stan client and the turn server supports the same very strong algorithm, then the authorization server could generate according this algorithm any length key.
I mean, no, the authorization server and the turn server need to share cryptographic information and configuration information with each other, or else the authorization server can't create valid tokens that the turn server will accept. They can't. I mean, I'm not saying they have a live connection between each other that happens on every single call, but they have to be tightly configured together or this doesn't work.
So is there any case where the browser has to execute these MAC algorithms?
So the Stun client is using this algorithm and creating the message integrity to every Stun message using this. This is normally SH1 actually that is implemented in browsers. So we need this information to generate the key according to this information.
So I mean, I think that, you know, to Colin's point, like we could have the turn server give this information, and to a large extent, this is entirely a future concern. It's only 2 algorithms defined now. So all we really need is the key is at least long enough for the algorithms that the browser supports. So right now, like, you know, we could get by having always return a 16 or a 256-bit key, and things will work just fine. So I think for now we should focus on like what stuff do we need to expose to get the key properly pushed down into the peer connection, and then save like, you know, how do we figure out what does peer connection support, you know, for another time, because I think we could have that done as part of the protocol between the turn server and the OAuth server.
Anyhow, the new SH, so the new HMAC algorithm is in the new Stun draft, so it is coming, I guess. So I think at least we need to think about this. So this is why I thought that it is important to signal somehow from the Stun client this information back to the authorization server, according to RFC example. So on the next slide, I created a proposal to use this new attribute in the this is a DOM string in the RTC configuration, and my second proposal was to extend with the access token the credential dictionary. So only these 2 information needed, and this is what I updated my proposal and my pull request according this to somehow extract this information from the Stun and pass up and pass down the username, the credential, and the access token if the credential type is token. So actually, this is the main proposal, and on the slide 22. There was another concern about that we need to find a way to use parallel the 2 things, and I think if we implement that way, then we can use the username, password, and the old authentication type parallel and ordering the ICE servers URLs in the JSON. We could create some ordering and define the presence of the credential type. The last slide is about that I also added some correction that the in-access token is also needed if the credential type is token, and should throw access error and abort steps if the access token is omitted also. And these are mainly my changes. I have also one question about the discovering stun turn server. So what happens if the stun turn is not configured through the application, but it is discovered somehow, and how the peer connection would signal that it has discovered through, for example, Anycast or multicast DNS, the turn servers. So how could we later use this? So briefly, that's all.
So, Harold, Stefan, do you have any suggestion on next steps?
So I see that my name is attached to the comment about is this the way we want to do things in the future, with adding one more token, one more element to our dictionary every time we add a new mechanism. And I found after all this discussion, I don't care that much about it anymore. so I wouldn't see it as unreasonable to just accept this.
I mean, I would like to see an object instead of another parameter. I am concerned that we might have more stuff that we need to push down here, and having like a dictionary or way to contain that, rather than jamming it just in more attributes in the top level RTC ICE server, like seems like it would be time well spent.
Justin, what are these information? This is what I had mentioned, that the old client parameters, not all information is needed during the authentication, and the old client is, in my opinion, need to handle this and store this information, not the stun client inside the browser, not the ICE agent. So I think only the needed parameters are these three.
Right. But say we have another form of authentication later. Now we have more top-level things that only are used in certain contexts.
Yes, but maybe it needs different things. Yeah. So and different attributes and very different things. Yeah. But then we need also to change the credential type and so on. So many things.
Well, I think that's fine, because like the idea would be the credential type would then tell you what the value of credential would be. That if credential type is OAuth, then you get a token object. If it's password, then you get a DOM string, which is the password. And I think that would sort of set us up well for if we need to add more things for the OAuth, or if we have different credential types in the future. We don't need to have all that stuff packed into the top level dictionary.
It seems like it seems like a good change to me. And I also want to make sure that the credential type is not token, right? That like we're going to have different types of token later, so let's call it an OAuth 2 token or whatever. Let's make a name for the type of token it is.
So anyway, I think it's a pretty minor cosmetic change to this. We can discuss and debug.
Yeah, so, Mithy, I think you had a proposal for doing exactly that in your other pull request some time ago. So it's not a great change. I don't mind.
Okay, so yes, I have two proposals. Yeah, the what Justin mentioned also to put everything outside, but it was not simple to implement, I think, and there was also contrast, not pros only, and I think the small change it is easier to implement, but
so there's one interesting property, which is that if you put in a union inside a dictionary, then actually it gets more complicated to have more variants in the union. and not get a type error than if you add more names inside the dictionary. So for extensibility, adding more attributes might actually be slightly better. I'll defer to anyone who feels more strongly about how to write WebIDL, but that's my impression after having extended a few IDL things.
Okay, so I look forward to cooperate with any of you to work on this.
But now we discussed supplying more information down to the ICE agent, but I heard greater resistance on this reading out the supported MAC algorithms.
Yeah, I mean, that would be kind of unprecedented for using RTC configuration to do that. I'd prefer we not do that.
Should we skip that for this update and focus on supplying information down for the agent?
Well, it's clear, I mean, if we do discuss it, back to Nisi's original point, I think we need to write some text that clearly explains, like, how you deal with it and why you don't need this information and how you get it, because it's just going to cause confusion either way. So I don't really care whether we export it or not, but either way, I care that we have enough text that people can figure out how it works, which we don't right now.
Good point.
So that the text will have to say that the authorization server would supply enough key material for whatever algorithm we want to use.
Right. Well, if right now, if we always return a 256-bit key, things will be fine. But we should, write some text on, probably not for this document, but there should be some way of understanding how the turn server communicates with the auth server, as Colin said, so that it can tell it what size key to return.
Yep.
I mean, we probably should have put that in one of the other RMCs. We probably just missed it, but maybe we just need to go clean that up a little bit or something, or maybe we put it here. But somewhere we need that text, and we can figure out where.
So who's got the action item to file a bug on that in some tracker somewhere?
I'm glad to do it if you want, but it seems like Missie's really been driving this one into the ground and doing a good job of it. So,
Yep.
Look, Missy, let me know. If you want me to, I will. If you want to go do it, you go do it. Whatever I can do to help.
It would be great if you could help me, at least. I'm
new
here.
You might have to tell him where to file the bug if it's not on this.
Write it down as an action for both of us together. We'll go sort it out.
Okay.
Okay. Just one question, last question about the RFC thing. What I have mentioned. Is it worth to write something about this, or you are fine to skip this? So writing down what happens inside WebRTC browser context, this third-party authentication for STAN. So what are the differences? Because the actual RFC is not speaking about the STAN client and the old client interactions. So it is not detailing this.
I think it'd be really good in this WebRTC doc to have some, it's probably non-normative text. It's probably just some explanatory text that explains how the whole thing sort of fits together. Because people trying to use this is going to be the place where they're sort of reading something, right? So, I mean, look, your explanation of how it all fit together today on those made it much clearer. Let's just write a paragraph on that and put it in this document that explains how the whole system works. Because this isn't, look, we don't have a good document to put the system level information in this. I mean, I guess we could put it in the RTC web overview document or security document or something. I don't know, maybe it should go there, but we can. I think between Steph and Harold, others, we can figure out where to add that.
Right. I think it'd be good to at least write this down now, so we all, as a group, understand this, and then you figure out exactly what document it ends up in.
So write it as a PR request for the WebRTC doc, like you've got it right now, and then we may decide to move it or duplicate some of the text somewhere else. Does that sound good to everyone?
That sounds good. So
Works.
put in a section saying here's OAuth and here's the introduction, here's the details on how it applies. Yes. Okay. That's it.
Okay.
Okay. Let's go on.
Stefan, change of scribe.
Yeah, I can take over.
Thank you.
Okay. Issue 822. Fluffy?
Sure. So on this one, I'm going to get on in the next two slides to the actual meat of it. So at the TPAC meeting, we agreed in the broad sense to add these more definitive errors to be able to differentiate between different cases where, and highlight that that's, where the actual application program needs to be able to understand what happened, not just reporting for humans for future debugging processes or things like that, because those can go in the sort of comment strings. So I wrote up a draft on that was sort of, or a PR, and sort of took my first initial stab of that, and thank you kindly to Dan Burnett, who did a lot of the work and heavy lifting on getting that structure set up for the error from, and just copied the, it's the same way we did it in the get user media draft. So two issues got raised on this that I think are worth talking about. So next slide, please, 25. So the first was on the SDP, if there was a parsing error of the SDP and it was invalid SDP, I included reporting back the line number where the parser had encompassed the syntax error. And I think Harold reasonably asked, well, hey, is that needed for applications to actually react to, or is that just a convenient for debugging point of view for is that meant for humans or is that meant for machines? Basically the question. It's good point. I think that why this gets used to repair from is SDP doesn't really have ways to express mandatory to understand attributes. So sometimes people put in proprietary extensions that use something that's not valid syntax with the idea it will cause a syntax error if it's received by something that doesn't understand it. And the usual approach to dealing with that is to just yank out either of those lines or yank out the whole mline, mline section that corresponds to, and just zero out the port that it's on and basically not negotiate. And you see this happening sometimes where there's a baseline audio and video stream, and then maybe there was some proprietary things for multi-screen systems or SVC or other thing layered on top of it. So there is a very direct reaction you can take to it when you get these errors. I'm not saying most apps wouldn't want to do that. Most apps aren't going to be dealing with that type of SVC. But it'd be very convenient to know, and it's something that's pretty much, it's really hard to imagine the browser doesn't really know that when it's generating the error. In fact, they're already sort of coding it in the text string. This is just moving it out to error string stuff. So that's sort of my proposal on that. People got thoughts or issues on whether we should add this or not?
So this explanation actually made a bit of sense, and did address my concerns about whether it was valuable. It also gives us a good heuristic for what line number to return if we're not sure about what line number is, which is, as long as the line number is in the right M line, then it doesn't matter. Right.
Yeah. And look, Harold, I think it was a very valid comment on all of these. It's like, hey, is this really needed, right? I mean, right now that's what the question we should be asking about these errors is it really needed? So I think it's a good question. So the next one, let's go to the next slide, 26. This one, depending on some views of how identity works, this one's either probably not needed or probably needed, and it's a little gray either way. So let me explain what it is first of all. When we're doing the whole identity process, if you're not logged into the identity, if the browser is not logged into the identity server when it goes to try and sign one of these tokens, you're going to get an error. You have to log in, and that can't really be done by the identity server JavaScript. That needs to be propagated back to the main application so it can go, oh wow, I need to render some user interface that tells the user to log in, maybe pop up another window or something like that. and it needs to know the URL of where the person's supposed to log in. So that's all agreed upon. That's all a strong part of our existing design. Now, the question is how we get back when this error happens of you need to log in, how we get back the URL where you would try and log in. And right now we have an attribute on one of the objects in the PC which can report back a single URL. And that's sort of what we have there right now. And the issue is how many identity providers you can have. So right now the draft is deliberately fairly vague on whether you can call set identity provider more than once. Well, if you can certainly call set identity provider 2 times. The question is does that set 2 identity providers, and we try and insert identity assertions from both of the identity providers from the calling side, and then the caller could use either one of those to verify whichever one if it trusted either one of them. Or if you call it twice, but calling it the second time, just overwrite the identity provider that was set the first time. Now, the draft is vague on that topic because we've always been a little bit unclear and we're missing probably some of the text. I think that the way things are moving, we certainly want to keep open options of having multiple identity providers, and we probably want to support multiple identity providers. Part of the changes needed to support multiple identity providers was the fingerprint draft in the SDP that Krister's been writing to very much clear up and allow multiple fingerprints. It doesn't make sense without that. So we needed that sorted out first. That's getting sorted out. If we're going to have multiple identity providers, then they're going to have different login URLs. And if you just start out the browser, you're not logged into either of your identity providers, you try and make a call, and you're going to get back 2 errors. Login identity provider A, login identity provider B. We could probably make this work with the single attribute thing that we have today, where it's an attribute in one of our objects and it doesn't come back in the error. And we could probably say, well, the last one wins, you try again, then you try again, you get another error back, and you get a different login URL in the error condition this time, and you use it. And so, it's a little bit like the old Unix error no. You have a single global variable for expressing errors happening on 2 different identity providers. If we're going to have multiple identity providers, I think there's a strong argument that it's probably cleaner to just return the URL in the error object, because it's when you get the error object is exactly the time you want the URL and you want to do something with it. I think if we're going to go with if we view having multiple identity providers in the future, there's a very strong argument, I'd make a strong argument for putting it in the error. If we're only going to have one identity provider ever, then I think it's a toss-up whether it's the attribute like we have it today or we add it in the error. It sort of doesn't make a big difference to me. So let me first of all ask, did that explanation make sense? And then we can get into, well, what should we do? So first of all, did people even understand what I was talking about?
I think I understood it. And my takeaway was that we call several identity provider twice, find what happens. Otherwise, applications written for one browser is not another browser, and that's not acceptable. It will be fine to say that there's a defined error that you get if you try to set 2 identity providers, but it's not fine to say that, yes, this works without an error, but it has different effects on 2 different browsers. So yes, you have to clean this up.
Right. Okay. Yeah, totally agree. Okay. So, I guess the question is, should we leave this sort of pending open? The question, should I open a separate bug of do we allow multiple identity providers, and then pending the resolution of that, come back to try and decide whether we put this one attribute in the error or not? Or would that be the right way to proceed?
Tim Pampson, yeah, I think you need to split that out. I think there's some complexity there. For a start, the naming's wrong. You can't possibly call it set identity provider and then call it multiple times with different values and stack them up. That's just too confusing.
Okay. We don't have Martin on the call, do we? Or Ecker? Okay. So Harold, let me propose what I'll do to move forward. I will pull this error string out of the PR request on errors, okay, because it's clearly we don't know what to do with it yet, so that we can move forward that PR request otherwise. I will open a new bug, which is about do we allow multiple identity providers, and I will open a new bug about this specific error return thing, and I will mark it. I'll put a note in it that says, hey, we're going to not worry about this one until we resolve the previous one on whether we support multiple identity providers. Is that everyone happy with that sort of path? I can hear crickets. Okay. Sure. I return the call to the chair.
Okay. I pressed the mute button in WebEx and it muted me 2 minutes later. That's interesting.
Oh, sorry. Go ahead, Harold.
Okay, next.
Taylor?
859. Taylor.
One of the admins to call in user 1 so I can use the conference room phone instead of my laptop phone.
Sorry, what has to be done?
So, Dom, you need to unmute call-in user 1.
It's like if you can hear me.
It looks unmuted now.
But okay.
Yep, we hear you.
Oh. Great.
I think you need to.
Okay, there we go. Sorry, are we good now?
Yep. So.
All right. So this issue is mainly editorial. We have behavior defined in JSEP that when a rollback occurs, if the session description that's being rolled back associated a mid with the transceiver or added a transceiver, then the rollback undoes those things. So the mid will be set back to null if it was set by the reverted description, and the transceiver would be removed from the peer connection set of transceivers if it was added, unless it was attached via add track, which is something we've discussed at length before. So I don't think the PR is already merged. I don't think that is very controversial. Are there any objections to what's displayed here?
None here.
So one thing I wanted to note before we move on is that I noticed that as JSEP's currently written, this is the only way a transceiver is removed from the peer connection set of transceivers. So even if it's stopped and the M line's rejected and it's recycled by something else, the transceiver would still stick around just in the stopped, unassociated state. I don't think it's really a problem, but it's just something we should be aware of. All right, moving on. So the issue here is that the negotiation needed flag section was still written in terms of tracks as opposed to transceivers. And now, transceivers are where all the SDP negotiation is encapsulated. And also I found there were some places I thought where the flag was set or cleared where it shouldn't have been, or not set or cleared where it should have been. So I tried to sort of just clean everything up and rewrite it in terms of transceivers. So now the flag's only updated in this PR when applying an answer or modifying the peer connection in the stable state. So if you do something in a non-stable state, nothing happens until you apply an answer, and then you can figure out is additional negotiation necessary or not. So for example, previously the flag was cleared when creating an answer. I don't think that makes much sense that just creating an answer would affect the state of the peer connection.
I think that was a level of thinking.
Okay, good. And also one thing I removed was in the description of RTP receiver, it mentions that when attributes are modified, a negotiation is triggered, and I don't think we have anything on the receiver that you can modify that would trigger negotiation needed, so I don't think that's valid anymore.
Yeah, there's no set parameters, so I don't know how that would happen.
Yeah, even so, set parameters on sender doesn't even require negotiation. All right, next slide, then we can go into the sort of detailed criteria I wrote for whether a negotiation is needed or not. The first two rules here regarding implementation-specific negotiation and the data section are just carried over from before. I think the meat of it is the rules for the transceivers. So for each transceiver, you need to negotiate if, first of all, the transceiver isn't yet associated, which means that it hasn't appeared in a description yet. That's pretty clear. If the direction is, has a send component and there's not an MSID line in the current local description, which is the same as the rule for tracks before. If you have a track, you need an MSID for it in the local description. Now it's just converted to transceivers essentially. All right, next slide. We move on to more rules for transceivers. I think this is where it gets a little complicated, and we may need to figure out what we mean by direction before we really answer this. But the goal of these rules is that negotiation needed is not set to true if an additional negotiation would not result in the desired direction. So for example, if you see the example there below in a bullet point, if the direction is set to send receive and I get a remote offer that's receive only, resulting in a negotiated direction of send only, even though the transceiver's direction does not match what was negotiated, it wouldn't make sense to set negotiation needed to true because, the remote peer is only offering to receive, and we know, or we can reasonably expect that we would get the same negotiated result. So this basically prevents, if the transceivers on the different peers have different negotiation direction preferences, you wouldn't get an endless string of offers and answers back and forth, trying playing a tug of war with the direction. So any comments on that? I don't know if you can try to take a little time to absorb the rules, but we have this, I split this into different rules for the offer and answer, where if the current description is an offer, then the direction has to match either the offer or answer. Meaning, if I offered X and you answered with Y, and my current direction is X, I'm just going to accept that the negotiated direction is Y. And then if I was the answer last time, then I take the intersection of the remote offered direction and my current preference. So
Taylor?
Yeah, go on.
This is Dan Burdett. I have a question.
Mm-hmm.
So this may be obvious, and I think based on what you just said it is. By the way, there's a really nasty echo.
Taylor, I think you need to mute your other device.
Okay, so anyway, so you gave your example there. And so let's say then the next thing that happens is that the remote offer is send receive, right? So after this, you've gone through this first example. Then again, you get another offer that's send and receive. One could say that, since the transceiver.direction is already send and receive, that nothing new would happen. There'd be no attempt to negotiate, even though there should be. But you're saying that won't happen because because the direction doesn't match the answer. That will force a renegotiation.
Right. So you're saying I was the answerer in this situation, and then I call set direction again with my current direction, or the thing that I last set.
What I'm saying is that you gave an example of, transceiver direction is send receive, remote offers receive only, answer is send only. Okay. So then the next time around, you're the receiver, and you receive another offer that says send receive. Wait, that doesn't matter. Okay. You would know that you did send only. Okay, it's fine.
Okay.
I guess I was thinking that, right, it's the offer, right? The offer sent, the offer said receive only. The offer changes his mind, right? So then the question is, how how does he indicate that, and how does that cause how does he change his mind to send receive, and have that cause a renegotiation?
I think the expectation is that if he changes his mind to send receive, he would send a new offer.
Right.
There's no need to wait for negotiation needed to happen before you send a new offer. You can send a new offer at any time.
Well, and in this case, if the remote peer was using the peer connection API, then they would change the direction by calling set direction, which, because send receive doesn't match what they offered, that would trigger negotiation needed. So the remote offer would renegotiate and you would go send receive. So basically, if both sides are peer connections, then you would always end up with, the intersection of the directions in a stable state.
Okay.
All right. So any more comments or objections to this? And I guess the last bullet point is just, again, pretty obvious. If the transceiver stopped, the MI needs to be rejected.
Yep.
All right. I guess moving on, and we can review the PR in more detail, but because the most a controversial part. All right, so this issue is mostly editorial. I think I noticed that in the peer connection section, there are some mentions of interactions between the user agent and ICE agent, but it doesn't look like they've been updated since we introduced the ICE transport, which now has its own state, and we have rules for when the ICE agent does this, update the peer connection ICE state, but now that state is an aggregate, and the actual state's on ICE transport, so it doesn't make much sense anymore. And then also, a lot of complexity has been added to the definitions of the ICE states, so it doesn't really suffice to cover, 3 possible state transitions anymore, because we have many more transitions possible. So I tried to address this in PR 920 by defining the interactions between the ICE agent and user agent in terms of an ICE transport, meaning that the ICE agent is responsible for indicating when the state of an individual transport changes. And the way I did this relies on the definitions of the enum, both the ICE transport enum and the aggregate one, instead of trying to document every possible state transition. So if you look on the next slide, it provides an example of how this looks. So when the ICE agent indicates that the transport state has changed, which means sort of the burden is on the ICE agent, a conceptual entity, to, implement a state change indication based on the definition of the enum. And when this occurs, a task is queued which updates the transport state, fires an event, updates the aggregate ICE state, fires an event if necessary, and updates the aggregate DTLS plus ICE state and fires an event if necessary. And that's pretty much all it is, and the similar text for the gathering state as well, and candidates being gathered. So, any comments or objections? All right, sounds like we're good.
Yeah. All right, so we're now on to issues in 902. Taylor?
Yeah, so the previous discussion about direction and negotiation needed assumed that when you call set direction, you're always going to, when you read the attribute, you're just going to get what you last set. But I wasn't sure if this is something we ever really decided on, and the argument might be made that it would make sense that the direction is actually what was last negotiated or what was in the last current description. So these examples sort of illustrate that point. So if I offer send receive, but what's negotiated is receive only, is the transceiver's direction send receive or send only? And if I was the answer, does the the direction reflect what was set, what was offered, or what was answered. Yeah, so that's the question. And we can move on to the next slide. So I think the tangible benefits of the direction changing when you apply description are really just that now you can see the direction that was negotiated without parsing SDP, and I guess it provides a nice, point in the API to reference for other, sequences of steps. But I think if that's the real issue, we could also just add a negotiated direction attribute to fulfill that goal. And I'd actually be in favor of that because I think, and we do have two notions of direction. It would be nice if they were cleanly separated. And another benefit would be that it makes the handling of negotiation needed for direction pretty simple. As opposed to the complicated rules on the previous slide, we can just say negotiation is needed if the direction doesn't match what's negotiated. Because after negotiation, it's guaranteed to match because it gets set. But I think the disadvantages are that now, say that I set a direction of send receive, but the other peer doesn't have anything to send yet, so it answers with receive only. If the direction then changed to send only on my side, now I'm sort of forced to continue saying, no, actually I want send receive because I want to keep offering to receive. So it forces you to call set direction in between each offer answer potentially. And then, this may also happen in the common use cases of add track. So now, you have to use the transceiver API even if you're using add track. Or we add even more special rules where maybe you have a combination send receive or send only direction, and I don't really want to start thinking about that. And it also sort of confuses what the direction attribute is because it's both direction that we want to negotiate and direction that was last negotiated. And it's sort of hard to distinguish between the two. So move on to the next slide. My recommendation is that we decide that saying a description does not change the direction attribute. It's always what you last set. And I think if we do want to expose a negotiated direction, it would be a good idea to have that as a separate attribute, but make clear that one direction is the direction preference, and it's always going to be what you last set, and the other is what was last negotiated, and what actually applies when it comes to whether I'm sending or receiving media.
Just a question, Taylor. Is the negotiated direction exposed via the active attribute? Can you necessarily figure out what that negotiated direction is by examining the sender and receiver active? Or is that not related?
In RTP encoding parameters, I wouldn't think so, no, because I would expect that's going to be what you last set in set parameters and sort of orthogonal and not related to negotiated action. So does everyone agree with the recommendation, and would we like to have a negotiated direction attribute or just leave it as direction set direction?
I would like to have a way to query the result of negotiation. If it matters to me, I should be able to see it.
Yeah.
One.
Yeah, +1 from this one.
Yeah.
I agree, and I'd also throw in that when someone calls add track, that is implicitly setting the preferred direction to send receive, whereas the negotiated direction doesn't have a value until after negotiations. So I think that's actually, we already have these two different states in there. They're just not exposed at the moment. Yes. So I like the idea of exposed.
And you can't start sending until the complete the negotiation, right?
Yeah, definitely. And if you have All right, so I will take the action to make a PR, adding a new attribute then.
All right. So 927 is about what happens when you call set direction. Some of the confusion Taylor just talked about might be cleared up by actually describing the steps. So this is the existing text. We've kind of gone over it. Doesn't take effect immediately, blah, blah, blah. And so the strawman proposal is the following steps. Basically, you take the argument to set direction, put it in new direction. If it's equal to the existing direction, you just abort these steps. There's nothing you need to do because you're not changing it. If it's a value that's not one of the legal ones, you throw an exception. You set the direction to the new direction, and then you mark the connection as needing negotiation. Does this make sense as to what set direction does?
In the last step, I think we need if transceiver direction is now different from currently negotiated direction, mark connection.
Oh, currently negotiated direction, right?
Yeah. In the last step, we can replace that with a pointer to, in my PR, the update negotiation needed flag.
The update negotiation needed flag, right.
Right.
Okay, so please write that down in the notes.
I'm working on it.
Yep, that sounds good.
Okay. Next. Taylor?
Yes, so this is what we left off the TPAC meeting discussing. So the caching went up. What we want is to have the UFRAG trickled with ICE candidates and also with end of candidates, along with preferably the mid as well, because we need the UFRAG in order to differentiate candidates from before an ICE restart and after in some circumstances. And the issue that's sort of been holding this up is that end of candidates works by setting the entire RTC ICE candidate to null, and that would be a logical place to put UFRAG. Now the question is, where does UFRAG go for end of candidates? So next slide. A couple of approaches that I think we've discussed previously are in PR 757, the UFRAG's added to RTC ICE candidate, and then end of candidates, instead of being a null candidate, it's a candidate with just a null candidate's SDP string. And PR 819 just adds UFRAG basically at a higher level as an optional argument to add ICE candidates, and then at the same level of the RTC ICE candidates in the ICE candidate event. And this would mean that it doesn't get a mid because the UFRAG is the only thing in the event then, which is probably not a big deal, but Triple ICE does say that the identifier for the media stream should be trickled. So next slide. This is what I think we sort of were informally discussing at the end of TPAC, where I think the issues with the previous proposals would be that they weren't, they tried to reuse the ICE candidate event, but they weren't completely backwards compatible. So I guess the solution here is to just define a new event and a new method to handle something that's either a candidate or end of candidates. And it's pretty similar to PR 757, except we're now calling it ICE action, or ICE. We could come up with a better name if we need to, but something that has an enum type and also has a UFRAG, where the candidate would now be not present in the dictionary if the type is not a candidate. And next slide. This is just the rest of the proposal. We have the enum with two values. I think one advantage of this is that it would be easy to extend in future versions of the spec, though maybe that's not a huge concern at this point. and then the event would expose this dictionary. And I put here also expose the ICE candidate interface where you can query attributes if you want to, but this isn't the thing that you would need to signal because the dictionary has all the information that you actually want to serialize and send over the signaling path. Next slide. The way this would be used is basically identical to how you'd use ICE candidate. It's just one event to hook up to and one method that handles events that go remotely. Next slide. Well, I guess at this point, whatever people's thoughts on this proposal, do we want to go ahead with this or go back to drawing board?
This is Janavar. Just a quick question. Why do we have why is get action and get candidate methods rather than just an attribute?
Let's see. I don't remember if there's a specific reason. I think that's minor detail we could work out later. I mean, whether like something is an interface or a dictionary, whether we have like an interface or a dictionary or two dictionaries, I think that's just sort of like WebIDL figuring out how to fit those together. But I think the crux of it is that we're adding a new event and new handle event interface.
Okay, thanks.
So the candidate is dictionaries, but the action, I think.
Right.
Well, RTC ICE candidate right now is an interface. RTC ICE candidate init is a dictionary that gets passed in. It's kind of confusing. So this is where the again, like I think we can work this out in the comments on the PR.
What concerns me more is actually the next slide. I like this, but I think we need to have a call, have a point on the next slide. It's 5 minutes to the top of the hour.
All right, next slide then.
Well, I just wanted to, since no one else was saying anything, I like the general solution of adding a different event and method to make it clear that this is different than what it was before. And there'll be some transition as apps move over to the new thing from the old thing, but long term, this is much more clean and robust than before.
So, Janavar here. Could you do a summary of why a new method? What kind of web compat is it protecting? I mean, I guess I have quite shallow uses of these APIs where I treat candidates mostly as black boxes. So, and this seems not necessary at all to me. So if someone could speak up and defend why we need to make new methods, that would be great.
Meaning that for you, CR7 enough because, I mean, end of candidates is just, basically looks like a candidate. It just has a null candidate string, and if you just serialize the dictionary and unserialize it, you'd be okay.
Yeah, I think I would prefer 757.
Okay. So.
Sorry, Tim Patton here. I vaguely remember the last time we talked about this, Eka jumped in with the problem that you might not be bundling, and then it would be ambiguous which of the two M lines you were talking about. Have we addressed that in this? I'm trying to catch up because I had to step away for a minute. But do we address that issue, or is it gone away? Or am I
with both this proposal and PR 757, the mid is in the dictionary, so there's enough identification.
And do we definitely decide that having like a flag that you set, like an RTC configuration to activate getting the new events is we definitely don't want to go down that path. So we prefer to do.
I would not.
No.
Yeah. So this is Dan Burnett. We discussed this for more than an hour at the face-to-face meeting, And I like this particular approach. I think it addresses all of the concerns that were raised at the face-to-face meeting, and it is future-proof as well.
Okay, thanks.
All right, so, I mean, we have a couple of people in support of this, and there's also the question of whether PR 757 is sufficient, just using the existing interfaces, and, you know, assuming applications treat the candidate as a black box. I think the only issue with PR 757 would be if they're not treating it as a black box and actually trying to, you know, get the candidate, they're not going to expect it to be null. So, I'm sorry, you were cutting off a little bit for me there. Can you repeat?
The other problem with 757 is, I believe, that you get the problem with the definition of end of candidates, which going to new interfaces solves.
Well, in that case, end of candidates was a null or, you know, missing candidate string. So
yes, it was impossible to tell.
Impossible to tell what?
Which transport the end of candidates was for.
But the end of candidates actually is an RTC ICE candidate that has a mid and a UFrag. It just has no SDP string, right? So I think we do have everything we need then. Again, the only issue I think with PR 757 is that applications might not expect a null candidate string. That could never be possible before. So
the point with 757 is that applications that wait for a null candidate will never detect it because it's a structure.
Oh, well, we could still have that null candidate for backwards compatibility, for like everything is done. I don't think that's an issue. But in the interest of time, sorry, go on.
No, I was just going to say, well, I just want to push 757 again. It sounds like it would solve all the issues other than, I mean, instead of null, could we even put in an empty string just to make it less likely that someone trips on it? I mean, it sounds like it would solve anything except advanced user that is somehow dumping the candidate string or interrogating it or parsing it. And hopefully those people are quick to update and check on Canary and nightly.
But there are also the clients that are expecting a null value and never get one, unless we have both a null value and
both.
Yeah, I think that's what we'd have to have.
Which would be kind of crazy, because then we have two things popping out that mean end of candidates.
And we would have end of candidate each transport and then an
we have to leave. I'm sorry. We've been kicked out of our conference room.
We have time out.
So this was marked as the end of the call, so
yeah. I think we're done.
I think we're done.
Yes. Okay. And verified media goes to the next call. Okay. Thank you all for coming.
Thank you.
We'll try to get the minutes out while we still remember what was supposed to be in them. Thank you.
Thank you. Bye.
Thanks. Bye.